طلاب، الفيديو التالي راح يوضح لنا عملية أو طريقة قياس الميلتينج بوينت. إن شاء الله تستفادون من هذا الفيديو.
Some substance will enter into the capillary tube. Now, tap the sealed end of the capillary tube on the glass plate gently and fill the capillary tube up to 2 to 3 millimeters. Attach the capillary tube to the thermometer using the thread. Take the 100 ml beaker containing liquid paraffin and place it over the hot plate. Insert the stirrer in the liquid paraffin bath. Clamp the thermometer carrying the capillary tube to the iron stand and immerse them in the bath of the liquid paraffin. Start heating the liquid paraffin bath slowly and stir the bath gently using the stirrer to ensure uniform heating. Note the temperature T1 when the naphthalene starts melting. Continue heating and note the temperature T2 when the naphthalene in the capillary tube is completely melted. The average of the two temperatures T1 and T2 gives the melting point of naphthalene. Precautions. Use dry and powdered sample for the determination of melting point. Packing of the powder should be uniform without any big air gaps between the solid particles. The liquid paraffin bath must be heated very slowly and the bath is stirred gently to ensure uniform heating. The bulb of the thermometer and the capillary attached to it should not touch the sides or the bottom of the beaker.
الفيديو التالي راح يوضح لنا طريقة قياس الميلتينج بوينت باستخدام الميلتينج بوينت apparatus اللي هو هذا الجهاز اللي أمامكم.
The heating is controlled electrically by means of a rheostat. In this equipment, the rheostat is activated by turning the orange knob. This also illuminates the digital display of the temperature. Rapid heating of the sample is possible by switching on the rapid heat switch. And to aid reading the temperature, the display can be held at its current value by pressing the whole display switch. In this apparatus, again the heating is controlled by the rheostat, which is activated by the switch on the front, which also activates a lamp inside the equipment for viewing. Rapid heating again is possible by activation of the boost heater with the switch on the left. I shall now show you how to prepare a sample for melting point determination. For the measurement, we shall use this apparatus. The sample for melting point measurement needs to be finely ground. This you can do using a spatula, pressing the sample firmly onto the surface of a clock glass. Alternatively, and more satisfactorily, the sample can be ground in a pestle and mortar. The sample tube for melting point measurement needs to be sealed at one end using the Bunsen flame. Hold the tube in the edge of the flame and rotate gently between the fingers. The blob of glass quickly seals the end of the tube. Don't leave the tube in the flame over long. The blob will become too large and will prevent insertion of the tube into the melting point apparatus. Always remember to return the Bunsen flame to the yellow position for safety. When the tube has cooled, insert the sample by pressing the open end of the tube into the ground sample. Tap the end of the tube firmly on the bench when the sample will fall to the bottom. Alternatively, the use of the serrated edge of some tweezers or the milled edge of a coin is possible. The sample is now ready for insertion into the melting point apparatus. We shall now make a rough melting point measurement using the boost heater. Switch on the rheostat heater, which also activates the light, and switch on the boost heater. Using a fresh sample of the material, we shall now make an accurate melting point measurement. Switch on the heater and lamp and use the boost heater until the temperature rises to 15 centigrade degrees below the rough melting point. When the temperature is roughly 15 centigrade degrees below the rough melting point, switch off the boost heater and adjust the rheostat so that the rate of rise of temperature is approximately 2 to 3 centigrade degrees per minute. In your notebooks, you should note the temperature at which the sample begins to soften, the temperature at which the bulk of the sample has melted, and the temperature at which melting is complete. For a pure compound, the range over which that occurs should be only 0.5 to 1 centigrade degree.